All right, everyone, we're going to be talking about vectors. So this problem says scalar product of two vectors. So the first obvious question is, what is scalar product? And there's a couple of ways to think about this. And the easiest way in my mind has been like this. Let's say we have vector A. This is just an example, so nothing to do with the problem that we're looking at here, but just imagine vector B. And a way to think about scalar product is to consider it like this. What amount of vector A is contributing in the same direction as vector B, so that combined interaction. And so to draw this out visually, we can say like this, vector A has some horizontal component, in this case, is AX, that is in line with vector B. And so the scalar product of this is to say, well, whatever the magnitude of this AX is multiplied by the magnitude of the vector B. So the magnitude of vector B, that's easy. Let's just think about that too much. Just the magnitude of vector B. And the magnitude of AX, though, is a little bit different. If you remember back to our previous video, AX is simply the magnitude of A multiplied by cosine of the angle between vector A and vector B. And so that is what our scalar product is. And then if we write this out in an equation, scalar product, which we write like this, we say vector A dotted or dot vector B, scalar product, or also we call this a dot product, is equal to the magnitude of the first vector, vector A, times the magnitude second times cosine of the angle between those two. So this is a general equation that can be applied to basically any situation, and it's what we're going to be using for this problem here. So this problem specifically says, okay, we want to find the scalar, or it tells us actually the scalar product of vector A and vector B is 48.0 meters squared. So they just give us the answer, but they then leave out some other information that we need to figure out here. So this says that if we know that vector A has a magnitude of 9 meters and a direction of 28 degrees west of south, and vector B has a direction of 39 degrees south of east, what is the magnitude of vector B? And so we're going to draw that out just like this. And we'll say that just because they're talking about things in terms of north or rather west of south and south of east, we'll draw our coordinate system here. Oops. And so just to draw out this picture, we'll draw out these vectors. Vector A has magnitude of 9 meters and a direction of 28 degrees west of south. The 28 degrees west of south, I'm just kind of guessing here, it's going to look something like this. That's our vector A. A little angle there. We'll say that, we'll label that 28 degrees. Right, west of south, meaning it's starting from the south, going straight down, going 28 degrees to the west. Then for vector B has a direction of 39 degrees south of east. So starting at our eastward direction here, all the way to the right, go 39 degrees south of that. Great, so we got our two vectors, and we want to know now what is the magnitude of vector B, right? So they told us, actually, let me label this here. Vector A, they told us that the magnitude or the length of this vector was 9 meters. But the magnitude of B, we don't know what that is. That's what we're trying to solve. We'll take this piece by piece. First off, I can already say, well, they tell us in the first sentence here that the scalar product is 48.0 squared equals the magnitude of vector A, which they also tell us, they say right here, magnitude of vector A is 9 meters. So magnitude of B, we don't know what that is, but write it in red just so we know we're solving for this thing. Magnitude of B times cosine of the angle between vector A and vector B. Not immediately obvious, they don't tell us that number, but they give us enough information where we can figure it out. Look back at our picture here, and we can say, well, from vector A, we have to go 28 degrees this way, and then kind of easy way to figure this out, at least the way I did it, was say, okay, we have to go then, 90 degrees, and then we just have to go backwards again, 39 degrees. Another way to write that out, we have to go for theta, I'll write it over here, our angle was 28 degrees, and we can go another 90 degrees, but then, we've gone too far, we have to go back 39 degrees to get to our vector B. So we can do that quick calculation, our calculator, that's, I think it comes out to 79 degrees. And we can plug that into our equation here, cosine of 79 degrees. Then solving for the magnitude of vector b, what we're being asked for here is really easy. We just move things around. That's going to be equal to, let's see if I can get this right, 48.0 meters squared divided by 9.0 meters times cosine of 79 degrees. And again, that's just a calculator thing. We can plug that all in. This comes out to 28.0 meters. And that's our answer, the magnitude of vector b. So the important thing in this problem was understanding what a scalar product is, kind of baseline understanding what that is, both just like conceptually, which I think is important going forward. I want you to consider when you hear scalar product or dot product, think about that as like the two vectors contributing together, projecting one vector down onto the other, just like we were talking about at the beginning. And then, of course, the equation for that, you can derive from that understanding or memorize it. And then once you have that, solving a problem like this is super easy. And you're just plugging numbers in, making sure you're getting your angles right and drawing your picture, making sure everything makes sense. And that's pretty much it. So yeah, thanks for watching. Stay tuned for another physics video coming up.